Profit is maximized when marginal revenue, MR, from selling the product is equal to the marginal cost, MC, of producing it. But marginal revenue depends on how pricing is done. We will compare two modes of pricing, namely single pricing versus perfect price discrimination. And marginal cost, MC, depends on whether the firm is producing under increasing returns or diminishing returns. Specifically, we will talk about the cost curves of natural monopoly, where one firm is big enough to dominate the whole market. Single price, PSP, applies to all units sold. Therefore, PSP is an average price. That is, every buyer pays the same price even though some are willing to pay more. Discriminating price, PDP, applies only to the marginal unit sold. Therefore, PDP price is a marginal price. That is, every unit is sold at a different highest possible price. When a single pricing firm faces a downward sloping demand curve, it must search for the maximum profit price. As the price searcher lowers its price, total revenue will first increase when sales increases faster than price decreases. That is, when the elasticity of demand is greater than 1. Total revenue, TR, would reach a maximum when sales increases no faster than price decreases. That is, when elasticity of demand is equal to 1. Then total revenue decreases as sales increases slower than price decreases. That is, when the elasticity of demand is less than 1. If the firm can sell each unit of output according to the buyer's willingness to pay, that is, the reservation price, the total revenue generated will be much larger and reaches its maximum when price charged is equal to 0. This total revenue generated through perfect price discrimination can be called total willingness to pay, TWP. Because single price is an average price, single pricing sellers TR is affected by the elasticity of demand. TR max out when elasticity is equal to 1. Because discriminating price is a marginal price, price discriminating sellers TR, that is TWP, max out only when price is 0. From the single seller's TR curve, we can derive the marginal revenue, MRSP, at any output level from the slope of TR. From the discriminating prices TR curve, TWP, we can derive the marginal revenue, MRDP, at any output level from the slope of TWP. MRDP is the same as the marginal revenue to pay, MWP. TR reaches its maximum when MRSP is equal to 0. This happens midpoint down the straight line demand curve. TWP reaches its maximum when MRDP is 0. This happens at the end of the demand curve, MWP. Under single pricing, marginal revenue, MR, is less than price, P, because price must be lowered for all units in order to sell just one more unit. Under discriminating pricing, MR that is MWP, is equal to price because each unit is sold at a different price. The U-shaped ATC and MC curves are typical of firms under diminishing returns, where the optimal capacity of the fixed input is soon reached, leading to high variable costs. In some cases, higher fixed cost can be traded off for lower variable costs. Think computer software, where the high fixed cost of development leads to very low variable cost of duplicating the codes. When fixed cost is very high and variable cost is very low, ATC will not reach its minimum until a very high output level. A natural monopoly results, since the market is only big enough for one firm. Let's keep the low fixed cost and high variable cost model on the right panel for comparison, with the natural monopoly cost curves on the left panel. Observation 1. Fixed cost is very high with the natural monopoly. Compare with the low fixed cost model. Observation 2. Variable cost increases very slowly with the natural monopoly compared to the low fixed cost model. Observation 3. MC is below ATC consistently under natural monopoly. Observation 4. For the same high output level, the natural monopoly ATC is lower than the low fixed cost model. With these two sets of cost curves, we can now compare profit maximization under single pricing versus perfect price discrimination. The single pricing monopolist will maximize profit by setting MRSP equal to MC. At MRSP equal to MC, output is too low to take advantage of the scale economy, and profit TR minus TC is too low even though price is quite high. But a price discriminating monopolist with the same cost curves would be able to produce much higher output level, QDP, with a much higher profit by setting MRDP equal to MC. Observation 1. The price discriminating firm can achieve higher output and higher profit because its total revenue, TWP, reflects the full marginal price for every unit, while the total revenue of the single pricing firm reflects the same average price for every unit. Observation 2. The maximum profit output, QSP, of the single pricing monopoly is too low to exploit the maximum efficiency output, where P is equal to MC, of a declining ATC at QSP2. Observation 3. The single pricing firm cannot produce QSP2 without incurring a substantial loss. Therefore, regulators cannot require a natural monopoly to charge a price equal to MC. Observation 4. The most regulators can do is to require the natural monopoly to set a price equal to ATC. But profit is zero when P is equal to ATC. Observation 5. At zero profit output QSP3, the output level is still below the maximum efficiency output at QSP2, where P is equal to MC. Observation 6. Given the same cost curves, the price discriminating monopoly would naturally produce at the maximum efficiency output, where P is equal to MC, because its MR is equal to P. Observation 7. Even if ATC is entirely above the demand curve, where not even a single pricing monopoly would want to produce, perfect price discrimination can still ensure profit for the natural monopoly without any government regulation.